Satellite constellations spoiling the view. I'm Tonya Hall, and joining me is Dr. Connie Walker, scientist at NSF's NOIRLab. Welcome, Connie.
Hi, thank you. It's great to be here.
And next up, we have Dr. Jeffrey Hall, director of the Lowell Observatory in Flagstaff, Arizona. Welcome, Jeff.
Hi, Tonya. Hi, everyone. Nice to be here.
And welcome to both of you. Dr. Walker, I'm going to start with you. What's the Satcon1 report and why was it written?
Well, about May of 2019, astronomers for the most part were surprised about a flood of satellites that were launched, about 60 of them, and it looked like a string of pearls across the sky for a few weeks to a month or two. And we knew that that had implications for the future. So we started trying to have discussions with SpaceX, which were the people who launched the Starlink satellites. They were very amenable to talking with us, and we actually got the okay from the National Science Foundation and got some funding, and NOIRLab spearheaded the workshop that resulted from it, with a lot of help from the AAS and Lowell Observatory and other people across the world, actually. And so this resulted in some studies that we did with the help of SpaceX to try to mitigate some solutions, because we foresaw that the visibility of these satellites would become an issue in terms of research done in astronomy and in terms of what people would actually see as everyday, in their everyday lives. So Satcon1 was the workshop that we had at the end of June, beginning of July, and a report came out of that, and it was like a 130-page report, but we actually have a nice section at the front. It's only about 24 pages, and it does summarize very succinctly and very well, and has a lot of good evidence by about 40 people across the world that helped write this, who are scientists in the field and people from industry. And it's feasible in some regards, the kind of results that they have said are good solutions, but it's not going to be entirely mitigation proof. I hate to say it, but it's true.
So Jeff, up for you. Specifically, how do these satellite constellations interfere with observations in visible light and near infrared?
Right, so the satellites, as Connie said, what surprised everybody was just how bright they are. There are many thousands of satellites up in orbit, but actually right now only about 200 that are visible to the unaided eye. And those are familiar things like the International Space Station, which you can clearly see. A lot of the bright satellites you see after sunset are things like big dead rocket bodies. So there's only a couple hundred of them. But the proposal from SpaceX was to launch 1,500, possibly with an expansion to many thousands, even tens of thousands. And SpaceX is just one of several operators proposing to launch these constellations. So suddenly you're facing the proposition of maybe 100,000 really bright satellites, which is a profound change to the night sky. And when something that bright tracks across the field of view of a sensitive astronomical detector, it's an immense impact. It completely will saturate the pixels that it tracks across. It introduces artifacts in the image and can render an image completely unusable for subsequent analysis.
Connie, what are some of the programs that are directly impacted by satellite constellations?
We did a really great study of that. There's about 9 different areas where this is really does a huge impact. And one of them, we can go back and forth, I think Jeff and I with these, but one of them is sensitivity on transient kind of events like gravitational waves or gamma ray bursts, or just things that are fleeting and that you don't know when exactly they're going to happen. So you need to have those sensitive instruments on the telescopes that are able to look very deep into space and have a very dark night sky with which to actually detect these kinds of things. And there's other things too that are like the undiscovered. Just think of Jocelyn Bell when she was on her radio telescope and she discovered, I mean, all the things that people have discovered just by serendipitously that led to a huge new area of astronomy. So, and what are some other sources, Jeff, that we might think of for the kinds of things that that need to have a dark sky?
Yeah, there are quite a few programs that could be impacted. Programs looking along the plane of the Earth's orbit for potentially hazardous asteroids are one. And there was a lot of discussion with scientists from the Vera Rubin Observatory, up and coming facility about to come online that has a very wide field of view, and it's searching for some of these transient phenomena that Connie was talking about. Those are the programs that will be most impacted. Some programs a little bit less so. For example, my research interests center on the variations of sun-like stars. So we observe by putting a single fiber optic onto a single star. And so that's only going to be impacted if a satellite happens to fly right through that tiny smidge of sky. But something like Vera Rubin with this very large field of view could be very significantly impacted, as could the multi-billion-dollar 30-meter telescope facilities that are on the drawing boards or under construction. This is the future of ground-based astronomy for the next several decades, and these are the very facilities that are at risk from a proliferation of bright satellites.
Exactly.
Jeff, what are some of the recommendations made in the report for mitigating these effects?
Yeah, there are several. I think one of the critical ones might seem a little counterintuitive, and that is fly the satellites low as possible. It might seem like you'd want them higher up because then they would be fainter, right? But actually, it's not the absolute brightness of the satellite that's the critical factor. It's how much light it stamps into a pixel. And the problem is when you launch a higher constellation, first of all, the satellites are visible for a much larger fraction of the night because they spend more time out of the Earth's shadow where they can reflect light. They also move more slowly. So they cross the image more slowly, and think of it like sort of searing light into the image. The faster they go, the less the impact. So these higher ones are going slower. And what emerged in some of the work, these huge telescopes focused at infinity, the low satellites are actually a little out of focus. And so the light is a little more spread out. You move them up and the light gets more concentrated. So that's one of the fundamental conclusions, is to fly them low. And then some of the other key things we can do right now, SpaceX has already been doing. So in January, they launched what they call DarkSat, which is a satellite that's just had its surface darkened. And that did indeed lower the satellite from about visual magnitude 5 to magnitude 6. And now they have launched or are launching what they call their visor sats, which actually have new components on them, a sunshade to block the sunlight from hitting one of these reflective surfaces. And those are getting somewhat fainter, down to about magnitude 7.5. And that's really important for the casual viewer of the night sky. At 7.5, you won't see them. And so all of these satellites up on station will not be visible to the unaided eye and crawling around the sky all night. It's still quite bright for an astronomical research telescope, but it does get down to the point that the folks at Vera Rubin feel like they can deal with some of the impacts in post-processing after images are acquired.
Connie, you mentioned the constellation operators have been receptive to the report's recommendations. So what can they do for the satellites already in orbit?
Well, a satellite's already in orbit. One of the things they can do is actually take the, I don't know if I have anything here. Yeah, I do. Okay, so I don't know if you can see this. This is like a Starlink satellite. It's L-shaped, right? And if you have it toward the Earth like this, you're going to get a lot of reflection from the satellite, especially from the solar panels that are here. If you have it edge on, they call it knife edge, you'll get very little surface that's focused towards the Earth, and you'll have less reflectance, right? So one of the things they can do, especially when it's orbital rays, when they're just going to their final orbit at 550 kilometers, is they actually can try as much as possible. Actually, they're flattened out at that point. They go up like this, and they can try as best they can to have the knife edge towards the Earth so to be less reflectant. And that's one of the things they can do. The others is that we have really only had the pleasure to work with SpaceX for the most part in getting mitigation results. So as Jeff mentioned, there's a couple of things they've already done and they're going to continue to do, is to have, for instance, first they had DarkSat, which only got down a couple of factors of brightness. So it only dimmed down by a factor of 2 or 2 point something. And then the VisorSat is up there now, and observations are just beginning with telescopes at various locations around the world, because most of the observatories are shut down at this point because of COVID-19. But those that are open are starting to take observations of the VisorSat. Well, actually, there's more than one up there now. Every one is going to be launched with a VisorSat. And in that case, it's like a sun shield on the parts that are the brightest of the Starlink satellites. But if we can take these lessons and work with the new, with other companies like OneWeb and like Kuiper project, which belongs to Amazon, these are the things we can talk about. It's not going to be the same thing for every company. Every set of parameters for their satellites are going to be completely different. For instance, OneWeb, we know for a fact, has a surface of their satellites reflect, they're much brighter. And thankfully they're twice the distance, but still they're up longer, as Jeff said. So we're gonna see that brightness for a while. But there's ways of working with the company, hopefully, to try to redress all these things. And I don't know if I actually answered your original question, but yeah, there's avoidance software that we can actually try to create to avoid this. Not all observatories will be able to have the funding to create such software or be able to actually implement the software, but there's attempts now to create avoidance software, as long as we're given good data for when the satellite is overhead, and at what time, then we could possibly implement avoidance software, even maybe with the help of the satellite companies. And there's other things like streak removal that they might be able to help us with too. I'm not really sure. I think it's more on the onus of the observatories. But as Jeff was mentioning, if you get down to 10th magnitude, if you get down a factor of 10 in the brightness, you might be able to remove the artifacts, not necessarily the streak itself, but at least if you get down to that, if you're dimmer by a factor of 10, you might be able to, there's little streaks that are on either side of the major streak, the trail of the satellite that you see in your, basically your photograph, that could possibly be removed. But again, this is going to take people power, it's going to take funding, it's going to take time, and that takes away from other things, like maybe the funding for a graduate student. I mean, it's really a very serious issue.
All right, then, Jeff, how do you see this ultimately shaking out?
Well, it's been very encouraging so far. This is clearly a situation where there is a conflict of purposes and interests. And, we've had a very good discussion with SpaceX. Back before the world turned upside down, Connie and I were both in Honolulu in January at the AAS meeting and had a chance to converse at length with Patricia Cooper and Jared Green from SpaceX. And, they're just good folks who think what they're doing is really cool. And they think what we do is really cool as well. And so they're trying to help. And the other companies have reached out. I think what's going to happen is there is going to be a sea change in what the character of the sky looks like, at least to telescopes, because a lot of these things are going to go up there and they are going to be visible. What we are doing now with the Satcon1 report in the books, as it were, Connie and I are starting planning for Satcon2 sometime next spring, and where we took Satcon1 and focused it very intentionally on the technical aspects. How bright are these things? Can we simulate what these constellations will look like in the night sky? How can we mitigate it? We stayed away from policy, right? But now we need to get to policy because it's kind of a wild west up there. And the thing that we point out very explicitly in the Satcon1 report, we're fortunate to have SpaceX that actually cares about their impact. What if an operator came along who just didn't care and had the resources and the business plan? There's nothing to stop somebody technically from launching a visible eye constellation of thousands of satellites wherever they want. And so we really need to get some ground rules in place up there. And that's where Satcon2 will be pointed, is to establishing that. And that will have to be an international effort and really involve pieces and information that goes to the UN, because you need a body, an international body that can make those decisions. One country can't do it by itself.
I love it. The Wild West. Dr. Connie Walker, scientist at NSF's NOIRLab. If somebody wants to connect with you, Connie, maybe they want to find out more about the work that you're doing or this report, how can they do that?
Well, I'd be very happy to receive emails. My email address is cwalker@noao.edu, and I believe that email address will be changing soon, but I'm sure that Tonya will update it on the website.
Thanks again, Connie. And Dr. Jeff Hall, director of the Lowell Observatory in Flagstaff, Arizona. If somebody wants to connect with you, Jeff, what's the best way they can do that?
Right. Well, you can get me by email at JCH, or Juliet Charlie Hotel at Lowell. There's the spelling right there in my background, .edu. Or I'm Jeffrey C. Hall on Facebook or Twitter.
Sounds great. Thank you both so much for your time. And find more of my interviews right here or at tonyahall.net. Thanks for watching.